How are you, my friends? In this video, I'm presenting 6 old exams questions related to hyperbolas and general equations of shifted conics. These questions are coming from lectures 39 and 40. Remember, 40 was the last lecture in this course, pre-calculus course. Question number 1, graph the hyperbola 25y squared minus 4x squared is equal 100. After that, you can find the coordinates of the vertices, foci, find also the domain and range. First, we have to rearrange the equation. Let's divide by 100. So we get y squared over 4 minus x squared over 25 is equal to 1. This is a standard. It's a vertical because the positive number here, 4 under the y squared. So a squared is 4. So a plus or minus 2, b squared is 25, b plus or minus 5. So I can put the corners here of the fundamental rectangle, or we call it central box. The vertices are 0, 2, 0, minus 2. The foci 0 square root of 29, because in the hyperbola, we have the formula c squared, as you know, is equal a squared plus b squared. And this is the asymptotes. This is the range and the domain. Question number 2, find the equation of the hyperbola that passes through the point 61 with the slope of an asymptote. There are 2 asymptotes. The slope of one of them is 2. The center, HK, is C33. Transverse axis parallel to the x-axis. So we have a little sketch here. The center is 3, so I can write it here. This is the transverse axis between the 2 vertices here. You see, it's parallel to the x-axis, passing through the point 61, and the slope of one of the asymptotes is 2. So we can say, start with h here, 3 and k. Slope is 2. We know the slope of the asymptote is b over a, so b equals 2a. Let's call this equation star. Now, this is a horizontal transverse axis parallel to the x-axis. So we can write the equation as x minus h squared over a squared minus, see, a squared under the positive, minus y minus k squared over b squared is equal to 1. We have the center hk 3, so we can write it down. X minus 3 squared, y minus 3 squared. Now b, I can take it from star and put here 2a. Square it, all of it, see? So it becomes, and now also the point 61 lies on the hyperbola, so it will satisfy the equation. So I can write 6 here for the x and 1 for the y. See, the only variable here is a. 6 minus 3 squared over a squared minus 1 minus 3 squared over 4a squared is equal to 1. You can figure out what is a, please, before you see the next slide, if you like. So from the last slide, we see 6 minus 3 squared over a squared. That will be 9 over a squared minus 4 over 4a squared. Cancel the 4. We have here the same LCD. So 8 over a squared is 1. So a squared will be 8. Now we know from equation star, b is equal to a. Square both sides here. You get b squared is equal 4a squared. We have a squared there. So b squared will be 32. So I can write the equation of the hyperbola x minus 3 squared over 8 minus y minus 3 squared over 32 is equal to 1. Question number 3, find the point where the graph is tangent. We have to rearrange the equation, this one here, to know what is the graph. So I say 10y minus y is equal minus. Square both sides to know the basic graph. So I can square all this. See, I take 10 common factor, y minus 1, square it, square all this, including the minus and the radical. So this becomes 100, y minus 1 squared, and this becomes the minus will go, the square root will go, 100 plus 4x squared. So bring 4x squared in the other side and divide by 100. So look at what you get here. Y minus 1 squared over 1 minus x squared divided by 25 is equal to 1. This is hyperbola. But the given is this, you see? The given is not hyperbola. It is half hyperbola. This one is the complete hyperbola. And this one, the given y is equal negative. You see, y is negative. So this is half hyperbola. Why it's negative? There is a 10 here. There is 100 plus something here, all squared. 100 plus something squared is more than the 10. So 10 minus this will be negative. So I draw the graph. It will be half hyperbola. The question is where the graph is tangent to the x at the origin. That's the answer there. Now, question number 4 says, find the equation and the vertices of the hyperbola having foci 11, 2 and minus 9, 2, and eccentricity equals to 5 over 4. I will make a little sketch here. If I put the f11, 2 and f prime minus 9, 2, I can see that the hyperbola will look like this. Now the eccentricity is 5 over 4. This is c over a by the formula. We know that the transverse axis is horizontal and foci lie on this axis. Center is the midpoint of f prime. So I can use the midpoint formula to get C1 and 2, the center. This is H and K. C is the distance from the center to any focus. So it will be the absolute value of 11 minus 1. This is 11 minus 1 there. So it will be 10. C squared will be 100. So the eccentricity formula is E C over A. It's given 5 over 4. 10 is the C. A we can find. So cross multiply here. A will be 8, so A squared will be 64. Now we know for the hyperbolas, C squared is equal A squared plus B squared. So we can find B squared will be 36. Since this one is horizontal, so x minus 1 squared, remember h to k, 1 and 2, x minus 1 squared divided by 64, which is a squared, minus y minus 2 squared divided by 36 is equal to 1. The vertices, these are the formulas, minus 7 and 2, 9 and 2. Okay, so these are the blue ones. And the red are the foci. It's given minus 9 and 2, 11 and 2. Question number 5 is a nice question. Find the value or values of E if the graph of the equation 4x squared plus y squared plus 4 bracket x minus 2y plus E is a single point. There are two parts here. First, we have to look at the equation and try to complete the square. Then I will answer the two questions. Let's rearrange it here. Multiply 4x minus 8y. Let's complete the square on the x and the y. Take 4 as a common factor in the x only. So x squared plus x. This is coefficient of x is 1. Divide by 2 half. Square it. You add 1 over 4. Subtract 1 over 4. Y squared, already the coefficient of y squared is 1. So minus 8 divided by 2 minus 4. Square it. You add 16, subtract 16. Now let's simplify this. 4, x plus half all squared plus y minus 4 all squared. And there is 4 times minus 1 over 4. That's minus 1. And there is a minus 16, so minus 17. If you take it in the other side, it will be 17 minus e. This is the constant, the number on the right side. Now, a part, if this is a single point, that means something squared plus something squared should be 0 to make it single point. So 17 minus e equals to 0, so e equals 17. Now, to have empty set or no graph, this number on the right side should be negative. So we say 17 minus e less than 0, which is negative. So the values of the e, bring e on this side. E will be from 17 up to infinity open interval. Question number 6, what do the equations represent? We have A, B, C, 3 parts. All of them, you need to complete the square on the X and complete the square on the Y. We have seen many examples in lectures 39 and 40 for completing the square. Please, you can do it yourself. I will put here the answer. Part A, the standard form after completing the square, it will look like x minus 3 squared over 4 plus y plus 1 squared over 36 is equal to 1. That will be an ellipse. The second one will be y minus 4 squared over 36 minus x plus 1 squared over 4 is equal to 1. This is a hyperbola. And the last one is y plus 1 squared is equal minus 10 bracket x minus 2. This is a parabola. Now the answers are here as usual. For other examples, please, you can see the videos on pre-calculus course lectures 39 and 40, hyperbolas and shifted conics equations. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening. Bye.